Hello, Mr. Betts here. I want to take a look at one example of partial fractions. So, using partial fractions to rewrite an integrand that's a little more complicated just because we have three factors in the denominator instead of what we have seen in the past, which is two. So, we're going to approach this problem the same way. So, let me rewrite this off to the side. By the way, if I were doing this side work on a piece of paper, I wouldn't write it underneath. I would write it off to the side, but I don't have the space for it here. And essentially, what I want to approach this as is like I said, the same thing, except we're going to have three fractions that added together are going to give us this expression. So I'll put a over x plus 1 plus b over 2x minus 1 plus c over x minus 3. And I'm going to write out now what this would look like if we got a common denominator and added them all together. So our common denominator obviously is going to be this expression here. So to get each one, I'm going to multiply it by the two denominators that are not below it. So for a, I'm going to multiply by 2x minus 1 and x minus 3. So a times 2x minus 1 times x minus 3 plus b times x plus 1 times x minus 3 plus c times x plus 1 times 2x minus 1. And all of that will be over x plus 1 times 2x minus 1 times x minus 3. Now, like we did with two fractions, we can do the same thing. We're going to make some choices for x here that are going to make these problems pretty convenient. So the first one I'm going to choose is I'm going to say x equals -1. So if x is equal to -1, what's going to happen is we're going to get a 0 here and we're going to get a 0 here. So the only term we're dealing with is this one. So plugging -1 in here, we're going to have 10 plus 42 minus 4. So that'll be 52 minus 4 is 48. And then plugging -1 in, we're going to have a times -3 times -4, which will be 12a. So we get a equals 4. All right, then I'm going to choose, let's do x equals 1/2. So if x is 1/2, we're going to have, it's going to require a little bit of arithmetic here, 10/4 minus 21 minus 4. So that's going to be 5/2 minus 21 minus 4. So 5/2 minus 25, or 5/2 minus 50/2, which is going to be -45/2. And then with the 1/2, this term and this term are both going to be 0. And all we have to worry about is this one. So plugging 1/2 in for b, this is also going to require a little bit of arithmetic. So it's going to be b times 3/2, and then 1/2 minus 3 is -5/2. So we're going to get -15/4 times b. So then solving for b, we're going to multiply by 4 over 15 and negative. So we're going to get 6 equals b. Okay, last one, we're going to say x equals 3. So for x equals 3, we're going to have 10 times 9 is 90, minus 126. So we're at -36, minus 4 is -40. And then -3, we're looking at this one. So we're going to have c times -2, and then -7. So 14c. I think I made a mistake there. So 390 minus 126 is negative 36. Minus 4 is 40. Okay. And then 3, I put a negative 3 in there. So that's going to be C times 4 times 5, which is 20C. And we get C equals negative 2. So we can rewrite this entire thing as the antiderivative of, so A is 4, so 4 over x plus 1. B is 6, so plus 6 over 2x minus 1. C is negative 2, so minus 2 over x minus 3. Put all of that in parentheses, times dx. So just term by term, all of these are going to involve natural logs. The one we have to be careful about is the one that has that 2 there. So I'll talk about that when we get to it. So this is going to be 4 natural log of the absolute value of x plus 1 plus, so this one, we have the natural log of the absolute value of 2x minus 1. If we're thinking about taking the derivative to reverse our antiderivative, the chain rule says we're going to multiply by 2. So I need to divide by 2, and instead of a 6 coefficient, I'm going to have a 3 for a coefficient. So when I take the derivative, that 2 times 3 is going to give me the 6. This is one where substitution might be a good choice just to make sure you don't make a mistake. And then the last one, we're going to have 2 natural log of the absolute value of x minus 3. And then for our antiderivative, don't forget your plus c. And there you have it.